You take a photo on your phone. You put it in your pocket. A few minutes later, you open your laptop, and there it is, the exact same photo. You didn't email it to yourself. You didn't plug in a single cable. It just appeared, like magic. Or when you start a movie on your living room TV, pause it, and then finish it on your tablet in bed. That seamless, effortless transition is not magic. It's the cloud. Now imagine a world without it. A world with no Netflix, no Spotify, no Gmail. A world where every single photo you ever took lived only on the one device that took it. If you lost that device, the photos were gone. Forever. Imagine your company where every piece of software, every critical file, every customer record was stored on a single humming, oversized beige computer in a back closet. If the power went out or the hard drive failed or heaven forbid the office had a fire, everything vanished. Your entire business could be wiped out in an instant. That world isn't some distant past. For many, that was the reality just 15 or 20 years ago. The only thing that separates our hyper-connected, on-demand digital life from that fragile, disconnected world is a concept that we call the cloud. It is, without exaggeration, the single most important technology of the 21st century. It's the invisible engine that powers our entire global economy, our entertainment, and our daily lives. Yet, for something so critical, most people can't really explain what it is. It's this vague, abstract term. We imagine our data floating around in the actual sky. We hear about it in the news, our bosses talk about it in meetings, but what is it, really? That's the question we are going to answer. And not in a boring textbook way filled with impenetrable jargon. Over the next 80 minutes, you are going to gain a rock-solid, practical, and deep understanding of cloud computing. This isn't just for software engineers or IT pros. This is for the entrepreneur who wants to build a business without spending a fortune on hardware. It's for the marketing manager who uses cloud-based tools every single day and wants to understand how they actually work. It's for the student who wants a massive advantage in the job market. It's for anyone who wants to finally understand the technology that is fundamentally reshaping our world. By the end of this, you won't just be able to define the cloud. You'll understand how it works, why it matters, and how you can leverage its power. So let's start by getting rid of the idea of fluffy, white clouds in the sky. The first and most important thing to understand is this. The cloud is just someone else's computer. That's it. That's the big secret. It's not an abstract concept. It's a physical thing. It's millions of powerful, highly specialized computers, called servers, packed into gigantic, air-conditioned, fortress-like buildings called data centers all over the world. Buildings owned by companies like Amazon, Google, and Microsoft. And you, through the internet, can rent a tiny slice of those computers to do things for you. To make this crystal clear, let's use an analogy. Let's talk about electricity. Imagine it's the late 1800s. Electricity is a brand new revolutionary thing. If you wanted to power your factory or your home, you had one option. You had to build your own power generator. You'd have to buy a massive, expensive, noisy machine, install it in your backyard or your basement, buy fuel for it, and hire a specialized engineer just to keep the thing running. This created a lot of problems. First, the upfront cost was enormous. You had to buy a generator powerful enough to handle your busiest day, even though on most days you were only using a fraction of its capacity. All that extra and used power was just money wasted. Second, you were responsible for all the maintenance. If a part broke, your factory shut down until you could fix it. You had to worry about fuel, repairs, and upkeep. It was a constant headache. Third, it couldn't scale easily. What if your business suddenly took off and you needed twice as much power? You couldn't just magically make your generator bigger. You had to go through the long, expensive process of buying and installing a whole new one. And what if business slowed down? Too bad. You were stuck with that giant, expensive machine sitting there, burning a hole in your pocket. This is exactly how computing used to work for decades. If a company, let's say a new startup, wanted to launch a website, they had to do the digital equivalent of building their own power generator. They had to go out and buy physical computers, servers. They had to guess how much traffic their website would get, and buy servers powerful enough to handle a massive surge of users, even if 99% of the time the traffic was low. They had to put these servers somewhere, in a special room with heavy-duty air conditioning and a dedicated power supply. They had to hire a team of IT experts to install the software, manage the security, replace broken hard drives, and be on call 24/7 in case the website went down at 3 a.m. It was incredibly expensive, incredibly slow, and incredibly risky. A huge portion of a startup's initial funding would be spent on just buying hardware before they had a single customer. Then a revolutionary idea came along. What if, instead of every single person building their own personal power generator, a few companies built massive, incredibly efficient power plants? And then they just ran power lines to everyone's house. You wouldn't need a generator anymore. You could just plug your lights into a socket in the wall. Think about the benefits. The upfront cost disappears. You don't build a power plant. You just pay a small monthly bill for the electricity you actually use. All the maintenance, the power company handles it. They have teams of the world's best engineers making sure the power plants are secure, efficient, and always running. If a turbine breaks, you don't even know it happened. They have backups for their backups. And the best part? It's elastic. If you want to host a huge holiday party and plug in 1,000 lights, you just do it. The power grid handles the surge. You use more power, you pay a bit more that month. When the party's over, you unplug everything, and your bill goes right back down. You can scale your power usage up or down instantly on demand. This is cloud computing. Amazon with its Amazon Web Services or AWS, Google with Google Cloud, and Microsoft with Azure, they are the power plant companies. The massive billion-dollar data centers they've built all over the globe are the power plants. The internet is the power lines that run to your house and your business. And instead of renting electricity, you're renting computing resources. You can rent storage to hold your files and photos. You can rent computing power to run your website or analyze data. You can rent databases, networking, machine learning software, anything you can imagine. So when Netflix needs to stream a new hit show to millions of people at the exact same time, they don't have a giant room full of servers with the word Netflix on them. They just plug into the grid. They rent a colossal amount of computing power from Amazon's data centers. When the show is a massive hit and millions more people start watching, Netflix's systems automatically tell Amazon, "We need more power. A lot more." And AWS instantly provides it. When the hype dies down a few weeks later, they scale back down and their bill goes with it. This model, the shift from owning your own generator to plugging into a shared grid, is what has enabled the entire tech explosion of the last 15 years. It's the reason a couple of college kids in a dorm room can build an app that serves millions of users overnight, without ever buying a single physical server. They can rent a world-class, global-scale infrastructure for the price of a few pizzas. This is the fundamental concept. The cloud isn't a place. It's a model. It's a way of delivering computing services, storage, processing power, software, over the internet on a pay-as-you-go basis. It's the shift from buying, owning, and maintaining your own physical data centers and servers to accessing those same services from a provider like Amazon, Google, or Microsoft. So we've established the core idea. Moving from the personal, expensive, and rigid generator to the shared, cost-effective, and elastic power grid. This analogy is the key. And as we go deeper, you'll see how this simple idea applies to everything. But now that we understand the what and the why, we need to explore the how. How do companies actually plug into this digital grid? Turns out there isn't just one type of socket. There are 3 main ways to connect, and understanding the difference between them is the next critical step in mastering this entire subject. These 3 main ways are known as the cloud service models. Think of them not as different products but as different levels of service. It's a spectrum that balances control against convenience. And the best way to understand this spectrum is to forget about computers for a minute and think about pizza. Imagine you decide you want pizza for dinner. You have a few options. Option 1, you make it completely from scratch. You buy the flour, yeast, tomatoes, and cheese. You make the dough, you make the sauce, you grate the cheese. You use your own kitchen, your own oven, your own plates, and you eat at your own dining table. You control every single ingredient, every single step. This is the traditional on-premise approach. You own and manage everything. But let's say you don't want to deal with all that. You want an easier way. This brings us to our first cloud model, Infrastructure as a Service or IaaS. In our pizza analogy, IaaS is like going to the store and buying a take-and-bake pizza kit. The store provides the fundamental ingredients. The dough, the sauce, the cheese, the toppings, all assembled for you. They've handled the infrastructure of making a pizza. But your job isn't done. You still have to take it home, preheat your own oven, bake it, and serve it on your own plates. You manage the platform for cooking and eating it. In the tech world, IaaS is exactly this. A cloud provider like Amazon Web Services or AWS gives you the raw infrastructure components, virtual servers, storage, and networking. They give you the digital dough and sauce. But you are responsible for everything on top of that. You have to install the operating system, manage the security patches, install your databases, and run your application code. You have complete control over the software environment, but you don't have to worry about the physical servers, the data center's air conditioning, or a hard drive failing. You are renting the fundamental building blocks. This gives you incredible flexibility, but it also requires significant technical expertise. It's the choice for companies that need fine-grained control over their computing environment, perhaps to meet specific security or compliance requirements, or to run specialized, legacy software that can't be easily changed. But what if that's still too much work? You're a great baker, but you don't want to mess with ovens. You just want to focus on the final presentation. This leads us to the second model, platform as a service or PaaS. In our pizza story, PaaS is like ordering pizza delivery. The pizza place takes care of everything, making the dough, adding the toppings, and even baking it in their super hot oven. A cooked, ready-to-eat pizza arrives at your door. All you need to provide is the platform for consumption, the plates, the napkins, and a table to eat on. You've outsourced the infrastructure and the baking process. In the cloud, PaaS providers do the same. They manage the infrastructure, the servers, the storage, the networking, but they also manage the platform on top of it. This includes the operating system, the security patches, and the development tools. They give you a ready-made environment where you can just deploy and run your application. You, the developer, can focus purely on writing code, on building your app, without ever worrying about managing the underlying server or its operating system. You manage your application and its data, and that's it. Services like Heroku or Google App Engine are classic examples. You upload your code, and the platform handles the rest, automatically scaling it up or down as needed. It's a massive accelerator for development. The trade-off? You give up some control. You can't tweak the operating system or choose a specific version of the underlying software. You have to work within the environment the platform provides. Now, for the vast majority of us, even providing plates and a table is too much effort. We just want to eat pizza with zero hassle. This brings us to the third and most common cloud model, software as a service or SaaS. SaaS is simply dining out at the pizza restaurant. You walk in, sit down, and order. The restaurant handles literally everything. The ingredients, the oven, the cooking, the plate, the table, the drinks, even the cleanup afterwards. You don't manage anything except your choice of what to order. You are simply consuming the end product, the service. This is the cloud model you interact with every single day. SaaS is any software you access over the internet, usually through a subscription. Think about it, Gmail is SaaS. You don't manage the email servers, the operating systems, or the software code. You just log in and use it. Netflix is SaaS. You don't manage a massive video storage and streaming infrastructure. You just press play. Salesforce, Slack, Microsoft 365, Dropbox, these are all SaaS applications. The provider handles all the underlying complexity of the infrastructure, the platform, and the software itself. You just use it. It offers the ultimate convenience. The trade-off, of course, is that you have the least amount of control. You can't change the features of Gmail or the user interface of Netflix. You are a tenant in a massive multi-user system. So let's recap the pizza analogy. On-premise. You make everything from scratch at home. Infrastructure as a service, IaaS, a take-and-bake kit. You manage the baking and serving. Platform as a service, PaaS, pizza delivery. You manage the plates and table. Software as a service, SaaS, dining out. You manage nothing, you just eat. What's critical to understand is that these aren't just separate options. They're layers in a stack. Most SaaS applications are built on top of a PaaS, which in turn runs on top of an IaaS. The Salesforce SaaS application doesn't run on servers in their own basement. It runs on a massive infrastructure provided by an IaaS vendor. So why does this distinction matter so much? Because the choice between IaaS, PaaS, and SaaS is one of the most fundamental strategic decisions a company makes when moving to the cloud. It defines who is responsible for what. It's a constant tug of war between control and convenience. If you're a bank with highly specific security needs, you might choose IaaS to have total control over your virtual servers. If you're a tech startup in a race to build a new app, you'll choose PaaS to focus your small team on coding, not server administration. And nearly every company on the planet will use some form of SaaS for common business functions like email or accounting, because building your own from scratch would be a colossal waste of time and money. Understanding this as a service stack is like learning the grammar of the cloud. It allows you to understand what's actually being offered when a company says they're using the cloud. They're not just plugging into one thing, they're choosing a specific level of management and responsibility. But this choice of how you plug in is only half the story. The other half is deciding which grid to plug into, because not all clouds are created equal. Some are public utilities open to everyone. Others are private, walled gardens built for a single company. And some are a strange, powerful mix of both, giving businesses the ability to keep their most sensitive data in a fortress while still taking advantage of the vast power of the public internet. This choice of deployment model, public, private, or hybrid, is where the strategy gets really interesting. And this strategic choice is what separates the companies that merely use the cloud from the ones that truly master it. Let's break it down. First, you have the public cloud. This is the model you probably think of first. Giants like Amazon Web Services, Microsoft Azure, and Google Cloud Platform dominate this space. The best analogy for the public cloud is a massive, state-of-the-art apartment building. The building itself, with all its core infrastructure, the plumbing, the electricity, the foundation, the security at the front door, is owned and operated by a huge property management company, say Amazon. You, as a business, are simply renting an apartment, or maybe a few apartments. You get all the benefits of a prime location and incredible amenities without the headache and astronomical cost of building the skyscraper yourself. If you suddenly need more space because family is visiting, you can rent the apartment next door for a week. When they leave, you stop paying for it. This is elasticity in a nutshell. The public cloud offers incredible economies of scale. Because Amazon is buying servers and fiber optic cables by the million, the cost for you to rent a small piece of that is incredibly low. It's the ultimate pay-as-you-go model, democratizing access to computing power that was once the exclusive domain of Fortune 500 companies. The downside? You're sharing the building. While your apartment is secure, you're still living in a multi-tenant environment. For some, especially organizations with extreme security or regulatory requirements, this shared environment, no matter how secure, can be a non-starter. That brings us to the second model, the private cloud. If the public cloud is a bustling apartment building, the private cloud is your own custom-built, single-family home with a big fence around it. You own everything. You control everything. The hardware, the network, the data center. It's all yours, dedicated solely to your organization. You're not sharing resources with anyone. This gives you the ultimate level of control, security, and privacy. A major bank processing billions of sensitive financial transactions can't risk a noisy neighbor in a shared environment impacting its performance. A government intelligence agency simply cannot have its data sitting on the same physical server as a cat photo sharing app. The private cloud is their fortress, but this control comes at a steep price. You're responsible for everything. You have to buy the land, build the house, maintain the plumbing, fix the roof, and pay the massive electricity bill. It requires a huge capital investment upfront and a dedicated team of experts to run it. You get the ultimate in control, but you sacrifice the cost-effectiveness and easy scalability of the public model. For years, the debate was public versus private. It was a binary choice, but the reality of business is rarely that simple. Most large companies aren't starting from scratch. They have decades of existing IT infrastructure, or what we call legacy systems. They can't just throw it all away and move into a public cloud apartment overnight. And this is where the third and arguably most dominant model for large enterprises today comes into play, the hybrid cloud. Hybrid cloud is exactly what it sounds like. It's the best of both worlds. It's like owning your secure single-family home, but also renting a cheap, convenient storage unit downtown. You keep your most precious, irreplaceable, and private belongings, family heirlooms, sensitive documents, safe at home in your private cloud. But for your less critical stuff like seasonal decorations or bulk supplies you bought at Costco, you use the flexible, pay-as-you-go public cloud. This approach is powerful. A retailer, for instance, might run its day-to-day sales and inventory systems on its secure private cloud. But during the Black Friday rush, when their website traffic explodes by 1,000%, they can seamlessly burst into the public cloud, renting massive computing power for just a few days to handle the spike, and then scale back down when the rush is over. They get the security of private with the scalability and cost efficiency of public. This strategic orchestration, knowing what to keep in the house and what to put in the storage unit, is the hallmark of a modern, intelligent cloud strategy. So we have these three deployment models, public, private, and hybrid, that tell us where our computing resources are located. But that's only one dimension of the cloud. The other, and perhaps more critical dimension, answers the question, how much of the work do you actually want to do yourself? This brings us to the three fundamental service models of the cloud. You'll hear these acronyms everywhere: IaaS, PaaS, and SaaS. They stand for infrastructure as a service, platform as a service, and software as a service. Understanding the difference between these three is absolutely crucial. And the best way to understand them is with pizza. Let's imagine you want to have a pizza night. You have 4 ways to do it. First, there's the traditional on-premises way. This is making pizza completely from scratch at home. You are responsible for everything. You have to buy the ingredients, the flour, the yeast, the tomatoes, the cheese. You have to make the dough and the sauce. You need the kitchen infrastructure, the oven, the electricity, the gas, the pizza pan. You have to assemble it, bake it, and serve it on your own dining room table. You control every single element, but it's the maximum amount of work. This is how companies used to do all of their IT, owning the data centers, the servers, the networking gear, the databases, and writing the applications. All of it in-house. Now let's go to the first cloud service model. Infrastructure as a service, or IaaS. This is like going to the grocery store and buying a make-your-own pizza kit. The store provides you with the fundamental ingredients: the dough, the sauce, the cheese, the pepperoni. They've handled the basic infrastructure of pizza making. However, you still have to take it home, use your own oven, your own pans, and your own kitchen to assemble and bake it. You're still managing the platform and the final product. In the cloud world, an IaaS provider like Amazon Web Services gives you the raw infrastructure components: virtual servers, storage, and networking. They handle the physical data center, the cooling, the power, but you are responsible for installing the operating system, managing the database, and running your application on top of it. You're renting the raw ingredients. Next up is platform as a service, or PaaS. This is like ordering pizza for delivery. You call the pizza place, you tell them what you want, and they take care of almost everything. They have the ingredients, they have the oven, they have the expert chef to make the pizza perfectly. All you have to provide is the dining room table and the drinks. The finished pizza arrives at your door, ready to eat. In the cloud world, a PaaS provider gives you the infrastructure and the platform on top of it, the operating system, the development tools, the database management. All a developer has to do is provide their application code, their unique recipe, and the platform handles the rest. It allows developers to focus purely on building their app, not worrying about the underlying servers or operating system patches. Finally, we have the most common model, one you use every single day: software as a service, or SaaS. This is simply going out to a pizza restaurant. You don't worry about anything. You just walk in, sit down, order a pizza, and eat it. The restaurant handles everything: the ingredients, the oven, the chef, the table, the service, even the cleanup afterwards. You are simply consuming the final product. This is Netflix, this is Gmail, this is Salesforce, this is Dropbox. You don't manage the software, you don't manage the platform, you don't manage the infrastructure. You just log in through your web browser and use it. The software is delivered to you as a service, typically on a subscription basis. So you have this matrix. On one axis, you have the deployment model: public, private, or hybrid. On the other axis, you have the service model: IaaS, PaaS, or SaaS. Every cloud service fits somewhere in this grid. You could run a SaaS application like an internal email system on a private cloud. You could use an IaaS provider on the public cloud to build a brand new application from the ground up. These layers, IaaS, PaaS, and SaaS, aren't just technical jargon. They represent a fundamental shift in responsibility, an abstraction of complexity. With each step up the ladder from IaaS to SaaS, the cloud provider takes on more of the management burden, allowing you, the user, to focus on what actually matters to your business. This shift is not just about convenience. It's about speed, agility, and innovation. And understanding this transfer of power is the key to understanding the entire economic and technological revolution the cloud has unleashed. So how does this transfer of power actually work in practice? When a company decides to move to the cloud, what are they actually buying? What are they plugging into? It's not a single one-size-fits-all utility. Instead, the cloud offers different levels of service, each representing a different degree of shared responsibility. Think of it like a spectrum, with total do-it-yourself control on one end and complete hands-off convenience on the other. To really get this, let's step away from servers and data centers for a minute and talk about something far more delicious: pizza. Imagine you decide you want to serve pizza to your family. The traditional old-school way to do this, the equivalent of an on-premise data center, is to make it completely from scratch. What do you need? Well, first, you need the house itself, the dining room, the kitchen. That's your physical building. You need electricity and gas for the oven. That's your power and cooling. You need the oven itself, a refrigerator, a mixer. Those are your servers and hardware. Then you need the ingredients, the flour, water, yeast, tomatoes, cheese, pepperoni. That's your operating system and your raw data. And finally, you have to actually combine everything, knead the dough, make the sauce, assemble the pizza, and bake it. That's your application code, the thing that turns the raw ingredients into a finished product. In this made-at-home model, you are responsible for absolutely everything. You own the kitchen, you pay the utility bills, you buy the oven, you source all the ingredients, and you do all the labor. You have maximum control. You can use a special kind of flour, a secret family sauce recipe, bake it at an unconventional temperature. It's all up to you. But you also carry all the burden. If the oven breaks, you have to fix it. If you run out of cheese, you have to go to the store. It's a huge amount of work just to get to a single pizza. For decades, this was how all companies ran their technology. They owned the building, they bought the servers, they managed the power, they installed the operating systems, and they wrote the software. Total control, but also total responsibility and massive upfront cost. Now let's look at the first step into the cloud. This is called infrastructure as a service, or IaaS. In our pizza analogy, this is like going to a gourmet grocery store that sells take-and-bake pizza kits. Think about what the store provides. They provide the kitchen where the ingredients were prepped, the specialized ovens and mixers they used. They provide the pre-made pizza dough, the sauce, the grated cheese, the sliced pepperoni, all packaged up for you. Essentially, they've handled all the foundational infrastructure and raw materials. What do? You take this kit home to your own kitchen. You still need your own oven, your own electricity, and your own dining room table. You are responsible for assembling the pizza from the provided kit, baking it according to your preferences, and serving it. You manage the final product. This is exactly what infrastructure as a service is. A cloud provider like Amazon Web Services, Microsoft Azure, or Google Cloud gives you the fundamental building blocks of computing. They give you the virtual servers, the ovens. They give you the storage, the refrigerator space. They give you the networking, the plumbing and electricity. They manage the massive, complex data centers, the physical hardware, the cooling, and the power, so you don't have to. You just rent access to this raw infrastructure. You are still responsible for managing everything on top of it. You have to install your own operating system, manage security patches, install your database, and deploy and run your application code. You're renting the kitchen, but you're still the chef. IaaS gives you a massive head start by removing the need to build and manage a physical data center. It's the ultimate Lego set for tech companies. They get all the fundamental pieces they need, but they still have the flexibility and control to build whatever they want on top. But what if you don't want to be the chef? What if you just want to enjoy the pizza without worrying about baking times and oven temperatures? This brings us to the next level up, platform as a service, or PaaS. In our pizza world, this is pizza delivery. You pick up the phone, or more likely you open an app. You choose your toppings and your crust. You tell them what you want, and some time later a hot, fully cooked pizza arrives at your door. What did the pizza place manage for you? They managed their own kitchen, their own ovens, their own ingredients, and the entire cooking process. They took your order, your requirements, and they handled absolutely everything required to turn that into a finished, edible product. Your only responsibility: you have to provide the dining room, the table, the plates, and the drinks. You provide the platform to consume the pizza. This is precisely what platform as a service does. The cloud provider manages even more of the stack for you. They don't just provide the raw servers and storage like in IaaS. They also manage the operating systems, the security patches, the databases, and the underlying software environment. They provide a ready-made platform that is optimized for developers to build and run their applications. A developer using a PaaS solution doesn't have to worry about configuring a server or updating an operating system. They can just focus on what they do best, writing code. They upload their application code, their unique pizza recipe, to the platform, and the PaaS provider handles everything else. It figures out how much server power is needed, how to scale if more users show up, and how to keep the underlying system healthy and secure. It's an incredible accelerator for innovation because it removes enormous amounts of complexity, allowing developers to go from an idea to a working application in a fraction of the time. Okay, so we've gone from making everything from scratch to using a take-and-bake kit to getting pizza delivered. But there's one final level of convenience. This is the one most of us use every single day. This is software as a service, or SaaS. What is the SaaS of the pizza world? It's simply going out to a restaurant. You walk in, you sit down at a table they provide, you order a pizza from their menu, and they bring it to you on their plates. They handle everything. The building, the kitchen, the oven, the ingredients, the cooking, the serving, the table, the plates, and even the cleanup afterwards. Your entire experience is managed for you. You are simply a consumer of the final service. You don't have control over the recipe, and you can only order what's on the menu, but it's the easiest, most convenient way to get pizza. This is software as a service. These are finished, ready-to-use applications that you access over the internet, typically through a subscription. Think about the tools you use every day. Gmail is a SaaS application. You don't manage the email servers or the software code. You just log in and use it. Netflix is a SaaS application. You don't host the video files or manage the streaming servers. You just press play. Salesforce, Dropbox, Microsoft 365, these are all giant SaaS companies. You aren't building anything. You are consuming a finished product that the cloud company builds, maintains, and delivers to you. This is, by far, the most common way that people and businesses interact with the power of the cloud. So let's put it all together. On-premise is making pizza at home. IaaS is the take-and-bake kit. PaaS is pizza delivery. And SaaS is dining out at a restaurant. Each model represents a trade-off between control and convenience. The more you move from on-premise towards SaaS, the more responsibility you hand over to the cloud provider, and the less you have to manage yourself. This frees you up to focus on what actually matters to your business. A company that builds video editing software doesn't want to be in the business of managing server racks and air conditioning. By using IaaS or PaaS, they can focus on building the best possible video editing features, not on managing infrastructure. A small business doesn't want to build its own accounting software from scratch. By using a SaaS product like QuickBooks, they can get world-class accounting tools for a low monthly fee. This layered model of IaaS, PaaS, and SaaS is the fundamental structure of the cloud. It's what allows a tiny two-person startup to use the same powerful infrastructure as a Fortune 500 company. It's what allows businesses to experiment, to build, to scale, and to innovate at a speed that was once unimaginable. But this raises a new question. We understand these different models of service, these different ways of sharing responsibility. But where do these services actually live? Are they all in one giant public building? Or can you build your own private one? And what happens when you decide you want a mix of both? Those are the perfect questions to ask because they get to the heart of how cloud computing is actually deployed in the real world. This isn't just about what type of service you're using, but where that service is physically, or at least logically, located. Think of it like housing. You know you need a place to live, but do you rent an apartment, buy a house, or do some combination of the two? Each choice has massive implications for cost, control, and responsibility. Let's start with the most common model, the one most people think of when they hear the cloud. This is the public cloud. Imagine a colossal, state-of-the-art apartment building. It's owned and operated by a massive real estate company. Let's call them Cloud Realty. This building has everything. A gym, a pool, security, maintenance crews on call 24/7. You don't own your apartment. You rent it. You pay a monthly fee, and in return you get to use the space and all the amenities. If your air conditioner breaks, you don't fix it. You call the landlord. If you need a bigger apartment because your family is growing, you can just move to a larger unit in the same building, often on the same day. This is the public cloud. The giant landlords are companies like Amazon Web Services, Microsoft Azure, and Google Cloud. They own and operate the massive data centers, the servers, the storage, the networking gear, all the physical hardware. You, the customer, simply rent a slice of that infrastructure over the internet. You pay for what you use just like a utility bill. This is called a pay-as-you-go model, and it's revolutionary. You don't need to spend millions of dollars up front to build your own data center. You can start a global business from your garage with just a credit card. The advantages are enormous. The cost of entry is incredibly low. The scalability is practically infinite. If your app suddenly goes viral, you don't have to scramble to buy and install new servers. You just click a button and provision more resources from the public cloud's massive pool. The provider handles all the underlying maintenance, the hardware failures, the security of the physical building. It's all part of the rent. But like renting an apartment, there are trade-offs. You don't have total control. You can't knock down a wall or rewire the electricity. You have to abide by the landlord's rules. You're also sharing the building with other tenants. While the providers are incredibly good at isolating tenants from each other, some organizations with extremely sensitive data or strict regulatory requirements might be hesitant. They worry about the noisy neighbor problem. What if another tenant on the same physical server uses up all the resources? impacting your performance? It's rare, but it's a consideration. So, if the public cloud is like renting an apartment, what's the alternative? Well, what if you want total control? What if you have very specific, unique needs and want to build everything to your exact specifications? In the real world, you'd buy your own house. In the tech world, you'd build a private cloud. A private cloud is a cloud computing environment dedicated to a single organization. It's your own personal data center. You own the hardware. You control the network. You set all the rules. You can paint the walls any color you want, build a custom home theater in the basement, and install a 10-foot-high fence around the property. You have maximum control, maximum security, and maximum privacy. This is often the choice for government agencies, financial institutions, or healthcare organizations that handle highly sensitive data and have to comply with strict regulations like HIPAA or PCI DSS. They can't risk their data coexisting on the same hardware as other companies. They need to know exactly where their data is, who has access to it, and how it's being protected down to the very last detail. With a private cloud, they have that granular control. But just like owning a house, it comes with a hefty price tag and a lot of responsibility. You are the landlord now. You have to buy the land, build the house, and pay for all the materials up front. That's a massive capital expenditure. And once it's built, the work is just beginning. You're responsible for all the maintenance. When a server fails in the middle of the night, your team gets the call. When you need to upgrade your storage, you have to research, purchase, and install it yourself. You need a highly skilled IT staff to manage and maintain the entire thing. It's powerful, but it's expensive and complex. For years, the debate was public versus private. It was seen as an either/or choice. Rent the apartment or buy the house. But then people started asking a brilliant question. Why does it have to be either/or? Why can't we have both? This leads us to the third and increasingly popular model, the hybrid cloud. Imagine you own your beautiful, secure house. It's where you keep your most valuable possessions, your family photos, your sensitive documents. It's your private, controlled space. But your house isn't huge. What happens when you decide to throw a massive party for 300 people? You're not going to sell your house and buy a mansion just for one night. Instead, you rent a local event hall for the party. You use a public space for a temporary, high-demand event, while keeping your core, sensitive life back at your private home. That is the essence of a hybrid cloud. It's a strategy that combines a private cloud with one or more public cloud services, with proprietary software enabling communication between them. You get the best of both worlds. You can keep your most critical applications and sensitive data, your crown jewels, on your private cloud where you have maximum security and control. But for less sensitive tasks, or for tasks that require massive temporary scale, you can tap into the power and cost-effectiveness of the public cloud. This gives rise to an incredibly powerful concept called cloud bursting. Let's say you're an e-commerce company. You run your main website and your customer database on your private cloud, day in and day out. It runs perfectly, but then Black Friday hits. Suddenly, your website traffic explodes by 10,000%. Your private cloud can't handle the load. With a hybrid model, you don't crash. Instead, the workload automatically bursts out to the public cloud. You seamlessly tap into the public cloud's immense resources to handle that temporary spike in traffic. Your customers get a smooth, fast shopping experience, and you only pay for those extra resources for the few hours or days you actually need them. When the traffic dies down after the sale, the workload scales back to your private cloud. It's the ultimate in flexibility and cost efficiency. This hybrid approach allows businesses to modernize and innovate without having to throw away their existing investments in their on-premises data centers. They can migrate to the cloud at their own pace, moving certain applications over time while keeping others in-house. And just to add one more layer, you'll sometimes hear the term multi-cloud. This is slightly different from hybrid. A hybrid cloud is about mixing public and private. A multi-cloud strategy is when a company uses more than one public cloud provider. So instead of just renting an apartment from Cloud Realty, maybe they rent one from them, and also one from Azure Estates, and another from Google Properties. Why? To avoid being locked into a single vendor, to take advantage of the unique strengths of each provider. Maybe one is better at artificial intelligence, while another has better pricing on data storage and for disaster recovery. If a meteor hits one provider's data center, your business can keep running on the others. So these deployment models, public, private, and hybrid, are about the where. They define the architecture and who has ownership and responsibility. The public cloud is the ultimate rental, offering scalability and low cost. The private cloud is the custom-built home, offering maximum control and security. And the hybrid cloud is the savvy homeowner who gets the best of both worlds, combining the security of their own property with the flexibility of renting when they need it. So we have the service models of IaaS, PaaS, and SaaS. And now we have the where, the deployment models of public, private, and hybrid. But now it's time to talk about the who. Who are the titans, the giants of the industry that built these digital empires? And how did a Seattle bookstore end up dominating a multi-trillion-dollar industry? To understand the cloud titans, you have to understand a problem that every single online shopper created in the late 1990s. The problem was the holiday rush. For a company like Amazon, traffic would be relatively stable for 10 months of the year, and then for 2 months, November and December, it would explode. They had to build massive, expensive infrastructure, servers, storage, databases, that sat mostly idle for most of the year just to handle that holiday peak. It was incredibly inefficient and expensive. After the dot-com bust, Amazon started thinking. They had gotten really good at building and running massive, scalable, reliable computing infrastructure. Far better than almost anyone else on the planet. What if they could rent out their excess capacity during those 10 quiet months? What if they could turn their biggest cost center into a profit center? In 2003, two engineers, Benjamin Black and Chris Pinkham, wrote a paper outlining a vision for Amazon's infrastructure that was completely standardized, completely automated, and would rely on web services for everything from storage to computation. Jeff Bezos saw the paper and had an epiphany. He realized the most valuable thing they had built wasn't the website. It was the machinery behind the website. This was the birth of Amazon Web Services, or AWS. It wasn't a side project, it was a radical new business. In 2006, they launched their first two major services. First came the Simple Storage Service, or S3. Think of it as an infinite hard drive in the sky. You could store any amount of data, from a single photo to a Hollywood movie, and only pay for what you used. It was revolutionary. A few months later, they launched the Elastic Compute Cloud, or EC2. This was even bigger. EC2 allowed you to rent a virtual computer, a server, by the hour. You could spin one up in minutes, run your application, and then shut it down when you were done. No more buying expensive physical servers that took weeks to arrive. Suddenly, a college kid in a dorm room had access to the same world-class infrastructure as a Fortune 500 company. It completely leveled the playing field for innovation. This is how companies like Netflix, Airbnb, and Dropbox got their start. They didn't have to spend millions on data centers, they just swiped a credit card with AWS. And because AWS was the first to market with this model, they had a staggering 7-year head start before any serious competition emerged. They got to define the market, set the prices, and build a massive ecosystem of services while everyone else was still trying to figure out what cloud computing even was. The Seattle bookstore wasn't just selling books anymore. It was selling the digital ground upon which the modern internet would be built. While Amazon was building its empire, another giant was sleeping: Microsoft. For decades, Microsoft dominated the world of computing. Their business model was built on selling software that people installed on their own physical servers. Windows Server, SQL Server, Microsoft Office, these were cash cows. The cloud, this idea of renting computing instead of buying it, wasn't just a new market. It was an existential threat to their entire business. If everyone moved to the cloud, who would buy their software licenses? Their first attempt, launched in 2010, was called Windows Azure. Notice the name Windows Azure. It was heavily focused on their own technologies, a walled garden for Microsoft developers. It was a start, but it was niche. The real change happened when a man named Satya Nadella, who was running the Azure division at the time, became the CEO of Microsoft in 2014. Nadella saw the future with absolute clarity. He declared a new mantra for the company: cloud first, mobile first. He did something that was once unthinkable at Microsoft. He embraced the enemy. He opened Azure up to Linux, the open-source operating system that Microsoft's previous CEO had called a cancer. The name changed from Windows Azure to Microsoft Azure, a signal that this was a platform for everyone, not just Windows users. But Microsoft had a secret weapon that Amazon didn't: the enterprise. They already had a decades-long relationship with nearly every major corporation on the planet. Their salespeople were already in the boardrooms. They could go to a company like Ford or Coca-Cola and say, "You already use Windows, you already use Office 365. Why not move your servers to our cloud, Azure? We'll make it seamless. We'll even help you build a hybrid cloud, connecting your old data centers to our new ones." This hybrid strategy was brilliant. It gave large, cautious companies a gradual on-ramp to the cloud, and it's a major reason why Azure has grown at a breathtaking pace, becoming the clear number 2 player in the market. They turned their potential weakness, their legacy business, into their greatest strength. So you have Amazon, the pioneer, and Microsoft, the fast-following enterprise giant. But there's a third titan, the one many believe has the most powerful technology of all: Google. Think about it. Google was doing cloud before the term even existed. Since the late 90s, they had been building a planet-spanning computer to run search, Gmail, YouTube, and Maps. The scale of their internal infrastructure was, and still is, mind-boggling. They solved problems of data processing and global networking that no one else had even encountered yet. The technology they developed internally was legendary. Bigtable, a massive database. Spanner, a globally distributed database that could keep time across the entire planet. And most famously, Kubernetes, a system for managing and orchestrating software containers that has now become the industry standard. So why aren't they number 1? For one simple reason: for a long time they didn't see the cloud as a product to be sold to others. They were an advertising company powered by incredible engineering, not an enterprise sales company. Their first major cloud product, App Engine, launched in 2008, was a platform as a service, which was more restrictive than AWS infrastructure as a service model. They were late to offer the raw, flexible building blocks that developers loved from AWS. When they finally got serious with the Google Cloud Platform, or GCP, they had a lot of catching up to do in terms of sales, support, and the sheer number of services offered. But their strategy is clear: lead with superior technology. They are the go-to cloud for data analytics, machine learning, and artificial intelligence. Companies that need to crunch massive datasets or build sophisticated AI models often turn to GCP, because Google has been doing it at a global scale for longer than anyone. Kubernetes, the open-source project they created, acts as a Trojan horse, getting their technology into data centers all over the world, making a future move to GCP that much easier. These three, AWS, Azure, and GCP, are the big 3 hyperscalers. They account for the vast majority of the public cloud market. AWS is the established leader, the everything store with the widest array of services. Azure is the enterprise powerhouse, the master of hybrid cloud. And GCP is the engineering and data-focused innovator, betting that the best tech will win in the long run. Of course, there are other players. IBM and Oracle are leveraging their own massive enterprise customer bases, particularly in specialized areas like finance and database management. And in China, Alibaba Cloud is a dominant force, rivaling the scale of the American giants within its home market. But the global battle, the one shaping the future of technology, is this 3-way race. It's a war fought not with soldiers, but with data centers, fiber optic cables, and armies of software engineers. Each is spending tens of billions of dollars every single year to get an edge. So now we know the who. We know the digital landlords who own the vast real estate of the cloud. But what are they actually selling? What's the difference between the services offered by AWS, Azure, and GCP? When you swipe your credit card, what do you actually get? Are you renting an empty plot of digital land and building everything yourself? Are you getting a prefabricated house where you just have to add furniture? Or are you moving into a fully furnished, all-inclusive hotel? That's the fundamental difference between the 3 main service models of the cloud. And understanding them is the next critical step in our journey. Let's start with that empty plot of land. This model is called Infrastructure as a Service, or IaaS. Think of it as the ultimate do-it-yourself kit for the digital world. The cloud provider like Amazon Web Services, Google Cloud, or Microsoft Azure gives you the foundational components. They give you the raw virtualized land. This includes virtual servers, what we call compute, along with networking capabilities and data storage. That's it. They've done the heavy lifting of building the massive data centers, managing the physical hardware, and ensuring the power never goes out. But from there, it's your show. You are the architect, the construction crew, and the interior designer. You have to install the operating system, whether that's Linux or Windows. You have to install the middleware, the databases, the runtimes that your applications need to function. You are responsible for patching, securing, and managing that entire software stack. And then, finally, on top of all that work, you can deploy your application and manage your data. This gives you an incredible amount of control and flexibility. If you have a highly specific, unique workload that requires a custom-configured environment, IaaS is your answer. It's like building a custom home. You get to choose exactly where the walls go, what kind of wiring to use, and how many outlets are in each room. You're not constrained by a pre-existing floor plan. Large enterprises like Netflix built their empire on IaaS. They needed granular control over their entire video delivery pipeline to optimize for performance on a global scale. They couldn't just use an off-the-shelf solution. They had to build their own, and IaaS gave them the fundamental building blocks to do it. The trade-off, of course, is responsibility. With great control comes great responsibility. You are on the hook for managing and securing almost everything above the raw hardware. But what if you don't want to be a construction foreman? What if you're a developer and artist and your masterpiece is code? You don't want to spend your days worrying about operating system patches or configuring network security groups. You just want a stable environment where you can build, test, and run your application. This brings us to the second model, the house that's already built, where the electricity and plumbing are all hooked up. This is platform as a service, or PaaS. With PaaS, the cloud provider manages not just the foundational infrastructure, the servers, storage, and networking, but also the entire platform on top of it. They handle the operating system, the system updates, the security patches, and the development tools. They give you a ready-made environment, a platform specifically designed for building and deploying applications. All you have to do is show up with your code and your data. You are the interior designer. You get to bring in the furniture, hang the art, and decide on the color scheme. But you don't have to worry about the foundation, the roof, or whether the water is running. This is a game changer for developers. It dramatically speeds up the development lifecycle. Instead of spending weeks setting up servers, they can focus on what they do best: writing code. Think of services like Heroku or Google App Engine. A small startup with a brilliant app idea can write their code, push it to the PaaS provider, and within minutes, their application is live on the internet, ready to scale to millions of users. The platform handles all the complex behind-the-scenes work of deploying the code to servers, balancing the load, and scaling up or down based on traffic. You, the developer, just focus on the application itself. You have less control than with IaaS. You can't, for instance, choose a niche operating system the platform doesn't support, but you're also freed from a mountain of operational headaches. Now let's go to the final destination on our real estate tour: the fully furnished, all-inclusive hotel. You don't own the land. You don't own the building. You don't even own the furniture in your room. You just show up with your suitcase, check in, and everything is managed for you. Room service, cleaning, maintenance, it's all included. You are simply a guest, a user of the service. This is software as a service, or SaaS, and it is by far the most common way we all interact with the cloud, often without even realizing it. SaaS is a fully baked, ready-to-use application that you access over the internet, typically through a web browser. Think about it. Do you use Gmail or Outlook for your email? That's SaaS. Do you use Dropbox or Google Drive to store your files? SaaS. Do you use Salesforce to manage customer relationships, Slack for team communication, or Office 365 for documents and spreadsheets? All SaaS. In this model, the provider manages absolutely everything: the infrastructure, the platform, the middleware, and the application software itself. You manage nothing. Your only responsibility is your own data and who you give access to. You have the least amount of control. You can't change the core features of Gmail, for example, but you also have the maximum level of convenience. You just sign up and start using it. The software is constantly updated for you. It's accessible from anywhere, and you don't have to worry about a single server, patch, or installation. So we have this clear spectrum. On one end, IaaS, where you manage the most but have the most control. In the middle, PaaS, a balance where you manage your app and the provider manages the platform. And on the other end, SaaS, where you manage almost nothing and simply use the software. From building it all to bringing your code to just showing up. Now, to make this crystal clear, let's use one more analogy that's a classic in the tech world for a reason: pizza as a service. Imagine you want pizza. The traditional old-school way is to do it all yourself on-premise in your own data center. This is like making pizza completely from scratch. You make the dough, you make the sauce, you grate the cheese, you prepare the toppings. You use your own oven, your own electricity, your own plates. You have total control over every ingredient, but it's a massive amount of work. Now let's move to the cloud. Infrastructure as a service, IaaS, is like buying the ingredients from the store. You buy the pre-made dough, the jar of sauce, the bag of cheese. You still have to assemble the pizza, use your own oven, set the temperature, and cook it. The grocery store provided the raw ingredients, the infrastructure, but you manage the platform and the final product. Next, platform as a service, PaaS. This is like ordering a take-and-bake pizza. The pizza shop assembles the entire pizza for you. The dough, sauce, cheese, and toppings are all perfectly arranged. They've managed the platform. All you have to do is take it home and put it in your own oven. You control the final deployment, the baking, but everything up to that point is handled for you. And finally, software as a service, SaaS. This is simply going to a restaurant, sitting down, and ordering a pizza. You don't worry about the ingredients, the assembly, or the oven. The chef prepares it, the waiter brings it to your table, and you just eat it. It's the ultimate convenience. You get the pizza you want with zero effort besides paying the bill. From a custom-built house to a furnished apartment to a hotel room. From making pizza from scratch to take and bake to dining out. These two perspectives should give you a rock-solid understanding of the fundamental ways cloud services are delivered. But this raises a crucial question. We know what these models are, but why would a business choose one over the other? Why would a company choose the hassle of IaaS when the convenience of SaaS exists? And why has this shift, from owning the kitchen to just ordering the pizza, become one of the most powerful economic and technological forces of the last 2 decades? The answer lies in a set of superpowers the cloud grants to anyone who uses it, benefits that were once the exclusive domain of the world's largest corporations. And unlocking those superpowers is our next stop. These benefits are the core of the cloud value proposition. They are the reasons why startups can suddenly compete with giants, and why established companies are racing to migrate their entire operations into the cloud. Think of them less as a list of features, and more as a set of fundamental advantages that rewrite the rules of technology and business. Let's start with the most profound one, the one that broke open the doors for a generation of entrepreneurs, trading massive upfront costs for small variable expenses. Imagine it's 2005. You have a brilliant idea for a new photo-sharing website. Before you can even write the first line of code, you have to play a terrifying guessing game. How many users will you have? 100? 1,000? 1,000,000? If you guess too low and buy a single cheap server, your site will crash the moment it gets any attention. If you guess too high and rent a massive, secure data center full of powerful servers, you'll burn through all your investment capital before you even launch. This is called capital expenditure, or CapEx. It's the giant, risky upfront bet you have to make on physical infrastructure. For decades, this barrier to entry protected large, established companies. They had the capital, you didn't. The cloud obliterates this barrier. With the cloud, there is no upfront cost for hardware. You don't buy servers. You don't sign a 5-year lease on a data center. You simply create an account, pull out a credit card, and start using the exact amount of computing power you need right now. You pay only for what you use when you use it, often down to the second. This transforms a crippling capital expenditure into a manageable operational expenditure, or OpEx. It's the difference between buying a power plant for your house versus just paying your monthly utility bill. The cloud grants you the superpower of cost efficiency, allowing you to redirect your precious capital from buying metal boxes to hiring talented people and building a better product. But what happens when your brilliant idea actually takes off? This brings us to the second superpower, the ability to scale elastically. Let's go back to your photo-sharing website. You launched it using a small, inexpensive virtual server in the cloud. It's working great for your first few hundred users. Then one day, a celebrity discovers your site and posts about it to their 20 million followers. Suddenly, you don't have a few hundred users trying to access your site. You have 200,000 all at once. In the old world, your single server would have melted. Your website would go down, your moment in the spotlight would be wasted, and your reputation would be ruined. You simply couldn't buy and install hundreds of new servers in the 5 minutes it took for that post to go viral. In the cloud world, something magical happens. The cloud platform sees this massive, sudden spike in traffic. Instantly and automatically, it begins to provision new virtual servers. 10, 50, 100, 500, whatever is needed. It seamlessly distributes the incoming traffic across all of them. Your website stays online, fast and responsive. Your new users have a fantastic experience. Then, a few hours later, as the traffic spike subsides, the cloud automatically shuts down those extra servers, and you stop paying for them. This is elasticity. It's the ability to acquire resources as you need them, and release them when you don't. It's not just about scaling up. It's also about scaling down, so you're never paying for idle capacity. This superpower allows businesses to handle unpredictable demand with perfect efficiency, whether it's a viral hit, a seasonal shopping rush, or the daily news cycle. So, you've saved a fortune on upfront costs and you can handle any amount of traffic. What's next? You need to innovate faster than your competition. This leads us to the third superpower: a dramatic increase in agility and speed. Your photo sharing site is a success, but now you want to add a cutting-edge feature: an AI-powered tool that automatically tags people and objects in photos. In the pre-cloud era, this would be a monumental undertaking. Your team would need to research, order, and wait for specialized, expensive servers with powerful GPUs. They'd have to install complex software, manage drivers, and configure network settings. The entire process of just getting the platform ready could take months. Months where your competitors are racing ahead. With the cloud, your developers can access a pre-built, fully managed machine learning service with a few clicks. They don't have to worry about the underlying hardware or software configuration. They can immediately start uploading their data and training their AI models on a massive, globally distributed supercomputer that they rent by the minute. What used to take a team of specialists months to build can now be accomplished by a single developer in an afternoon. The cloud isn't just a collection of virtual servers. It's a vast and ever-growing toolbox of sophisticated, high-level services, from databases and data warehouses to artificial intelligence, IoT, and quantum computing. This superpower of speed and agility allows teams to stop wasting time on the undifferentiated heavy lifting of managing infrastructure, and instead focus all their energy on what truly matters: writing code, experimenting with new ideas, and delivering value to customers faster than ever before. Now your site is feature-rich, cost-effective, and scalable. But your user base is growing, and you're getting emails from people in Europe and Asia complaining that the site feels slow for them. Physics is the culprit. Data takes time to travel across undersea cables. This is where the fourth superpower comes in: the ability to go global in minutes. To solve this latency problem in the old world, you would face an international nightmare. You'd have to lease data center space in Frankfurt and Tokyo, navigate different regulations, ship hardware across oceans, and hire local staff to manage it all. It would take a year and a massive budget. With a global cloud provider like AWS, Azure, or Google Cloud, they've already done the hard work. They have already invested billions to build dozens of data centers, or regions, all over the planet. From a single web-based console, you can choose to deploy a copy of your application in their Ireland region, their Singapore region, and their Brazil region. In a matter of minutes, your international users will be automatically directed to the data center closest to them, and their experience will be just as fast as for users in the United States. You have just deployed your application globally with a few clicks from your chair. This superpower of global reach instantly puts world-class, low-latency infrastructure at your fingertips, something that was once the exclusive domain of the world's most powerful multinational corporations. Finally, we have to consider the one thing that keeps every CEO up at night. What happens when things go wrong? A data center could lose power in a hurricane. A critical network connection could be cut. A server could fail. This brings us to the fifth and perhaps most crucial superpower: unprecedented reliability and disaster recovery. The major cloud providers design their infrastructure for failure. They don't just build one massive data center in a region. They build multiple, distinct data centers, called availability zones, miles apart from each other, with independent power, cooling, and networking. A well-architected cloud application runs across several of these zones simultaneously. So if one of them, an entire building full of tens of thousands of servers, is knocked offline by a flood or a power grid failure, your application doesn't even blink. Traffic is automatically and instantly rerouted to the healthy availability zones, and your users notice nothing. For even greater protection, the cloud allows you to easily replicate your entire application and its data to another region thousands of miles away. If a catastrophic event were to take out the entire east coast of the United States, you could fail over your entire operation to a live running copy in Oregon in a matter of minutes. This level of resilience used to cost millions of dollars in dedicated hardware and private network links. The cloud makes it accessible and affordable for everyone. Cost efficiency, elastic scale, speed and agility, global reach, and incredible reliability. These five superpowers working in concert are the engine of the cloud's dominance. They fundamentally changed the economics of starting and running a business. They democratized access to elite technology, unleashing a wave of innovation that has defined the 21st century. The cloud isn't just a different way to run a server. It's a different way to think, to build, and to compete in the modern world. And this new way of building software demanded a new set of tools, a new architecture designed not just to run in the cloud but to be born in it. This is the world of cloud native, and to understand it, We have to start with a problem that has caused more headaches, late nights, and arguments than almost any other in the history of software development. It's a 5-word phrase that every programmer dreads hearing. But it works on my machine. You see, for decades, developers would write code on their laptop, a machine with a very specific configuration. It had a certain version of the operating system, specific libraries, unique settings. The code worked perfectly there. But then they'd hand it over to be deployed on a server, a completely different environment. And suddenly everything would break. The code that was a masterpiece on the developer's laptop became a mess on the production server. This friction, this gap between development and operations, was a massive source of delay, bugs, and frustration. For years we tried to solve this. Virtual machines helped, as we discussed, by creating consistent server environments. But they were still big, slow to start, and carried the entire weight of a guest operating system. We needed something lighter, faster, more fundamental. The solution, when it arrived, was an act of pure genius, inspired not by computer science but by global trade: the shipping container. Before shipping containers, loading a ship was chaos. You had barrels of one size, crates of another, sacks of a third. It was slow, inefficient, and expensive. Then the standardized container came along. Suddenly, it didn't matter what was inside the box: wine, electronics, car parts. All that mattered was the box itself. The cranes, the ships, the trucks, they were all designed to handle one standard shape. It revolutionized logistics. A company called Docker did the exact same thing for software. They created the software equivalent of a shipping container. A developer could package their application, the code, the libraries, all its dependencies, into a single standardized isolated unit called a container. This container could then be moved from their laptop to a testing server to a production server, and it would run identically every single time. The "it works on my machine" problem was solved. Containers were a revolution. They were lightweight, starting in milliseconds, not minutes. You could run dozens of them on a single machine that might have only handled a few virtual machines. This allowed for a new style of architecture called microservices, where large monolithic applications were broken down into dozens or even hundreds of tiny independent services, each running in its own container. This made development faster, more flexible, and more resilient. If one small service failed, it didn't take down the entire application. But this incredible success created a new high-class problem. We went from managing a few large, clumsy servers to managing thousands or even tens of thousands of tiny, fast-moving containers. How do you deploy them? How do you connect them to each other? What happens when one fails? How do you scale them up when traffic spikes? Manually managing this new fleet of containers was an impossible task. We had created an orchestra of microservices, but we had no conductor. And that is when Google, one of the earliest pioneers of container technology, stepped in. They open-sourced an internal project they'd been using for years to manage their own massive containerized workloads. They called it Kubernetes. The name might sound intimidating, but its job is simple to understand. It's the conductor for our container orchestra. Kubernetes is a container orchestrator. You tell it the desired state of your application. I want to run 5 copies of my web server container and 3 copies of my database container, and they need to be able to talk to each other, and Kubernetes makes it happen. It's a master scheduler, finding the right servers to place your containers on. It's a self-healing system. If a container crashes, Kubernetes automatically starts a new one. It's a scaling engine. If traffic to your web server surges, Kubernetes can automatically add more containers to handle the load. Kubernetes became the new operating system for the cloud. It provided a universal layer of abstraction that worked across AWS, Azure, Google Cloud, and even on-premise data centers. It created a common language and a common set of tools for deploying and managing modern, cloud-native applications. This entire ecosystem, building with microservices, packaging with containers like Docker, and orchestrating with Kubernetes, is what we mean when we say cloud-native. It's about building applications that are designed from the ground up to leverage the elasticity, resilience, and scale of the cloud. The story of abstraction, however, doesn't stop there. As powerful as this new world was, you still had to think about servers. You had to provision a cluster of machines for Kubernetes to run on. You had to worry about patching them, securing them, and making sure you had enough capacity. The engineers and architects looked at this and asked a truly radical question. What if we could go even further? What if we didn't have to manage servers at all? Not virtual servers, not container clusters, nothing. What if we could just write code and have it run? This is the world of serverless computing. Now, the name is a bit of a misnomer. Of course, there are still servers somewhere. The magic is that you, the developer, no longer see them. You don't manage them, you don't provision them, you don't even think about them. They have been completely abstracted away by the cloud provider. In the most popular form of serverless, called functions as a service or FaaS, you write small single-purpose pieces of code called functions. A function might be designed to do one thing and one thing only: resize an image after it's been uploaded, process a payment after a customer clicks buy, or send a welcome email when a new user signs up. You upload this function to the cloud and then nothing happens. It doesn't run. It doesn't consume any resources. It doesn't cost you a single cent. It just sits there dormant, waiting to be triggered by an event. That event could be an HTTP request from a user, a new file appearing in a storage bucket, or a message being added to a queue. When the event occurs, the cloud provider instantly spins up the necessary compute resources, runs your function just long enough to handle that one event, and then shuts it all down again. The economic model is mind-bending. Imagine you only paid for electricity for the exact milliseconds a light bulb was on, and not for the time it was off. That's the serverless model. You are billed for the precise amount of compute time your code uses, often measured in fractions of a second. For applications with unpredictable or sporadic traffic, this can be phenomenally cost-effective compared to paying for a server that sits idle 99% of the time. But the real power of serverless is the philosophical shift it represents for developers. It is the ultimate expression of utility computing. You are no longer in the business of managing infrastructure. Your entire focus shifts to writing business logic, the code that actually creates value. This frees up immense mental energy and allows teams to innovate at a blistering pace. You can build incredibly complex, event-driven applications that scale automatically from 0 users to millions, without ever once having to think about a server's CPU or RAM. This progression, from physical servers to virtual machines to containers and finally to serverless functions, is a story of increasing abstraction. At each step, we've hidden more of the underlying complexity, allowing us to focus on higher-level problems. We've moved from managing hardware to managing operating systems to managing applications, and now to simply managing individual pieces of code. This shift from managing machines to managing logic is perhaps the most profound change the cloud has brought to the world of technology. But it also raises new questions. As the infrastructure becomes truly invisible, what are we actually building on? What are the new risks, the new complexities that emerge when you operate at this level of abstraction? What are the new frontiers of computing this unlocks? And where does this road ultimately lead? This road leads to a future where the very concept of a server becomes an archaic implementation detail, as irrelevant to the developer as the specific power plant is to you when you turn on a light. This is the world of serverless computing, or more accurately, functions as a service. If containers were about packaging your application so it could run anywhere, serverless is about not even thinking about the package. You simply write a small piece of code, a function that does one specific thing. Maybe it resizes an image when it's uploaded. Maybe it processes a payment when a customer clicks buy. You upload that function to the cloud, and you tell the cloud provider what event should trigger it. And that's it. You're done. You don't provision a server. You don't configure a container. You don't manage an operating system. You just write the code. The cloud provider handles everything else. When the trigger event happens, like a new photo appearing in a storage bucket, the cloud instantaneously spins up the necessary compute power, runs your function, and then shuts it all down. You pay only for the fraction of a second your code was actually running. It's the ultimate pay-as-you-go model. It's computing on demand in its purest form. This fundamentally changes how applications are built. Instead of one large monolithic program, you build a collection of dozens, or even hundreds of small independent functions that trigger each other like a chain of dominoes. It's a completely different way of thinking, one that fully embraces the ephemeral, event-driven nature of the cloud. But as our infrastructure becomes more invisible and centralized in these massive data centers, a new problem emerges: the speed of light. For many applications, a round trip of a few hundred milliseconds to a distant data center and back is perfectly fine. But what about a self-driving car that needs to make a split-second decision based on sensor data? What about a surgeon using an augmented reality headset to perform a remote operation? What about a factory floor full of IoT sensors that need to react instantly to prevent a failure? In these cases, even the slightest delay, the latency, can be catastrophic. The solution isn't to make the central cloud faster. It's to stop going there altogether. This is the frontier of edge computing. The idea is simple. If the data is being generated out here at the edge of the network, then the computing should happen at the edge too. Instead of sending raw video from a security camera all the way to a data center in Virginia for analysis, you put a small, powerful computer right next to the camera. This edge device can analyze the video in real time, identify a threat, and send only a tiny alert back to the central cloud, instead of terabytes of useless footage. Edge computing is the cloud in reverse. It's a decentralization. It's placing small pockets of cloud infrastructure, compute, storage, and networking closer to where the action is. In cell towers, in factory equipment, inside cars, in your local retail store. It's a nervous system for the planet with the central cloud as the brain, making the big strategic decisions, and the edge nodes as the reflexes, acting instantly and locally. This hybrid model gives us the best of both worlds. The massive scale and power of the centralized cloud, combined with the low latency, real-time responsiveness of local processing. And what are we running on this global interconnected fabric of central and edge computers? Increasingly, it's not just our websites and databases. It's intelligence itself. The next great abstraction in the cloud is artificial intelligence and machine learning as a service. For decades, building a useful AI was the exclusive domain of PhDs at major research universities and corporate labs. It required massive datasets, specialized hardware, and incredibly complex algorithms. The cloud has obliterated that barrier. Today, you can go to any major cloud provider and access pre-trained, world-class AI models through a simple API call. You don't need to understand neural networks to add image recognition to your app. You just send an image to an endpoint, and the cloud sends you back a list of objects it identified. You don't need to be a linguist to build a chatbot. You send text to a natural language processing service, and it tells you the user's intent. Speech to text, text to speech, translation, sentiment analysis, fraud detection. These incredibly complex capabilities are now available as simple pay-as-you-go utilities. The cloud providers have done the heavy lifting, training these giant models on unimaginable amounts of data, and now they are renting out access to their intelligence. This democratizes AI on a scale we've never seen, allowing any developer, any startup, to infuse their products with the level of intelligence that was science fiction just a decade ago. And if we look even further to the absolute bleeding edge, we see the cloud beginning to offer access to a completely new paradigm of computation: quantum computing. These machines, which operate on the bizarre principles of quantum mechanics, are not going to replace your laptop. They are terrible at most things classical computers are good at. But for a specific class of problems, like discovering new medicines, designing new materials, or breaking complex cryptographic codes, they promise an exponential leap in power. These devices are finicky, astronomically expensive, and require near absolute zero temperatures to operate. You will likely never own one, but through the cloud you can already rent time on one. Researchers and developers can now write quantum algorithms and run them on real quantum hardware, exploring a frontier that could redefine science and technology in the 21st century. It is the ultimate expression of the as-a-service model, providing access to a fundamentally new reality of computation. So where does this road ultimately lead? It leads to a world where the constraints of computing are no longer about hardware, location, or capital. The primary constraint is our own imagination. We began this journey talking about a simple problem: the hassle and expense of owning and managing a physical server. The solution, renting a virtual one, seemed like a simple, pragmatic fix. But that one idea set off a chain reaction of abstraction. Virtual machines gave way to containers. Containers are giving way to functions. Physical locations are being augmented by a global edge network. And on top of it all, we're layering intelligence and even quantum capabilities not as products to buy, but as services to call upon. The role of a technologist has changed forever. The heroes of the past were the ones who could build the best server, write the most efficient operating system, or manage the most complex data center. The heroes of today and tomorrow are architects and composers. They are the ones who can look at this vast menu of cloud services, this global, infinitely scalable computer, and creatively combine these powerful building blocks to solve human problems in new and unexpected ways. Cloud computing was never really about the clouds. It was about offloading complexity. It was about turning a scarce, expensive, and difficult resource into a simple, abundant, and accessible utility, just like electricity. By doing so, it has unshackled a generation of builders, dreamers, and creators from the tyranny of the physical machine. It allows a single person in their bedroom to access the same global infrastructure, the same artificial intelligence, the the same raw computing power as the largest corporations on Earth. The cloud is the great equalizer. It is the foundation upon which the next wave of human innovation is being built, and its story is still only in the first chapter.